Ramses, can you hear me? I'll be back in a minute. So should I start and record, or?
No, yeah, in a second. You can start if you want. I'm just trying to find it. I heard you around, but now I'm trying to find the link.
Okay.
Like there's no redirect. So where is it?
And should we record this one?
Yeah, I think so. Just to make sure that it's from the talk that we just had. I only have half. I don't know if that's because half is not processed yet by YouTube, or whether there's a maximum length.
Okay.
Channel. Oh.
We're good? So we're good. Okay, so, oh yes, I should take this out. Okay, so yeah, welcome to the introduction to Linux Shell. I am the SciNet analyst here that I'm going to go today over a few comments about Linux Shell. And my name is Bruno Mundin. My colleague Ramses is also going to help us. And so today, this is a short outline. So the first caveat is that we're not going to have time to see everything about Linux Shell. My goal today is just that you have the familiarity to survive around this environment, right? And then you can, from there, start looking at other stuff on your own. Of course, we have an advanced Linux Shell class as well that we go a little bit more in depth with more comments. But that's not the goal. My goal is not for you to be an expert today. It's just for introduce and for you to get some familiarity with the Linux shell. Okay. So for this, I will introduce the shells in a moment, and then we're going to talk a little bit about shell environment and shell variables. I'll mention quickly the file system, how your files are organized in your computer. Then we're going to go over several different commands, and then I'll try to type it in the commands myself, so we slow down the course, and then you have a chance also to play a little bit with them. Then we're going to talk a little bit about pipelines and redirection, I/O pipeline and redirection. And we're going to finish with the shell scripts. We're not going to go over too much about shell scripts, just a few simple constructs. In the advanced Linux shell, we'll go over more constructs of shell scripts, okay? So you might be asking yourself, what is a shell? So a shell is a meta program, a program that we use to run other programs, okay? Basically, all general purpose computers have a shell of some sort, right? For example, if you open a terminal in Linux or in Windows, right, you're going to see the shell prompt here waiting for you for the input, for example, in Linux there, and here in Windows, right? And it's just going to be there waiting for your input, right? This is a kind of a text shell where you type it in, all your commands that you need. It is also called command line interface, okay? But also there's another interface that you're very familiar with, right? If you look at your cell phone, the main screen of your smartphone, right, you usually have all these different commands, different programs to be launched as well, right? So this is some sort of a shell, but it's a graphical shell, right? It is also called graphical user interface. So you basically tap it in on the application that you want to use, and the shell will run that application for you, okay? So about these interfaces, right? I expect that all of you are here because you also want to work with HPC, right? High performance computing. And in this world, nobody, absolutely nobody uses the graphical user interface for high performance computing, right? And the reason for that is that basically one reason is history, right? On the first mainframes, the first supercomputers that were built, they only had the text shell, only had the command line interface, and it has been that way, and then you have a big inertia to change, right? The second reason is about the resources, because it is very expensive to run, let's say, one computer, and to have like hundreds of people logging into that computer and launch graphic user interfaces to interact with that computer. It is very expensive in terms of resources, right? You need lots of graphics card and so on. So that's another reason that people usually don't use graphical shell in the HPC machines. And of course, the GUIs are usually very slow over the network, right? You need to send a lot of data back and forth. There are some programs nowadays to try to overcome these two items here. But there are exceptions, right? We open exceptions if you want to do like visualization. Then yes, there is a way to work with GUIs. But if you really care about using HPC, you do need to learn how to use the command line interface, because that's how you're going to interact with these machines, okay? So it's also, I'm not suggesting that the Linux machines don't have a graphical user interface at all. They do. My desktop has, for example. It's just that the HPC machines, they don't, okay? Mainly for this reason, a little bit of inertia, and because of the resources that requires to have to provide that service. Okay, so what are the strengths of the graphical user interface, right? So usually it's very good at operating an existing system, right? If you have a desktop with all those windows and so on, right? It's very nice. It's ready for you to use. It is also useful if you just need to use existing functionality, right? You just need to press buttons, toggle switches here and there, right? Scroll down, up and down the bars and so on. So those functionalities is already baked in the software, right? So it's fantastic. It's ready for you, very intuitive, okay? So and also these kind of programs usually have a lot of functionality already there for you. So you just can use it. So it's very easy to learn. However, it is very hard to do if you have like a big task, right? Suppose that you need to do several different things to realize your work, right? To finish your work. Usually these programs, they don't save this, all the buttons that you clicked, right? They don't save all the boxes that you checked. So you need to find out a way of saving yourself. And whenever you need to redo this work, you need to go there and check all the boxes and toggle all the buttons and switches, right? So this is bad in this sense. And that's it is the opposite of the command line interface can allow you to do, right? What else I want to have? Okay, so the command line interface, it has a different approach, right? It's basically a blank canvas. You do whatever you want, right? It is text-based, so it is very expressive, right? It's the same reason why you write codes also in text. It's very, very expressive. You can do whatever you want, right? So it is very good at creating new things. If you need to use a command that it is already there, it's also good because those commands are doing just one thing, and it's fantastic for that. But you also can save your commands into a file and then reuse later whatever you did. So your work is not wasted in this sense, right? So for the command line interface, I just know only a few software that can do that. For example, there is a visualization software called Amira that after you put all the graphs, after you put all the commands that you toggle together, you put and you configure, then you can save that configuration for later and to open that back, right? But that's a rare case. In the most cases, you cannot save that. So in the command line interface is different. You basically type it in, all the commands, all the everything that you need to do your work, and then you save it into a file. Later on, if you need to repeat, you go there and reuse it, your work. Okay. It is hard to learn, but it's easy for big tasks. You can do complex tasks very easily. Okay, so that's basically the difference between command line interface and graphics user interface. Do you have any questions about this? Or? Okay. So the shell, let's get set it up. If you are in a Windows machine, you can start up the mobile X term. So does anyone with a Windows machine here? So I'll be typing the command, so you can also type it in together, okay? So open a terminal. For Mac, you can go to Applications, Utility, and Terminal, and then you drag to the dock, right? So you can always open quickly. Linux, you have there Xterm, eTerm, console. I like console because that's the desktop that I usually use. Okay, the terminal will just launch the shell. And the shell is what you are going to be interacting with, right? You're going to type in the commands there. And the shell provides access to file, network, and other programs. So you can do a lot of things with the shell. You type it in, the shell interprets them and performs the actions on its own. For example, you could launch other programs as well. The most common shell used is in Linux is Bash. At the time I was learning like TC shell and Bash, because one was good for one thing and the other one was good for another thing. Like one was good, TC shell was good for interactive shells, and Bash was good for batch. But nowadays this difference basically vanished, and everybody's using Bash for mostly everything. So yeah, there are others like TC shell, Corn shell, C shell, and so on, but we are not going to be using them today. So if you are using mobile Xterm, you can set this configuration on the settings configuration. You change your persistent home directory to a permanent location. So if you're using Windows machine with mobile Xterm, now it's a good time to set up your persistent home directory so you can work on it as we go. Okay, the command line prompt. So you have a terminal open, and then what do you see, right? You see what is called the command line prompt, right? So you have a prompt, and this, for example, is an example for the mobile Xterm. You have your username and the name of the computer, and here on a Mac, the username and the username and the computer name, right? And the prompt here waiting for you to type it in, a command. Here's an example on Linux. So I'm going to use the mobile extern prompt for this class, but this is highly configurable, and don't sweat about them. You can configure the way that you want, right? It's just for you to have a reference. It's just that to help you know which system you are and where in that system you are working on. Okay, our first set of commands, let's start by typing this in, and then as I type, I explain what we have here. Oops. So I just log into my account at Niagara, but you don't need to. If you're using your local system, your laptop, you can use that as for yourself. Oops, I think I went up. So the first thing that we're going to do, I'm going to type hello. And hello is just going to be the name of a variable. That's what is called a shell variable. And for me to assign a value to that shell variable, I have to type it equal. And then I type the value that I want to put in. In this case, it's a string. So I open the double quotes. I mean, doesn't need to on this example, but I'll just do it anyway. Okay, so, and I press enter, okay? So right now, the hello variable has the value word. How do we access that value? So I'm gonna use a command to show you how this is done in shell. The command is equal. Equal it just prints out to the screen whatever you type it in as an argument, right? So I'll type like hello common word. Okay, so basically it just prints out to the standard output that is in your screen the words hello word. Okay, now for me to access the value of the shell variable called word, I need to use the dollar sign. The dollar sign basically retrieves that value. Okay, so let's go type it in again, but instead of the hello, oops, I will type with the dollar sign. Oh, now I have hello. Yes, I should have done the other way. And okay, so now we have a hello word. So the dollar sign basically fetches the value of the shell variable called hello and prints out here that is word. Okay? So if you're getting any error message, it's probably because you have a different shell. So type just type bash, and then you're gonna have the bash shell. Questions about this? What do you mean?
For example, hello plain.
Yeah, if I put hello blank, what do you mean? Like this? No, then it's a command, right? And then this command doesn't exist. So bash will try to find that command called hello, right? So it doesn't exist. So, and the same, if I put just a dollar sign, it's try to find the command that is evaluated by the bash here. Hello has a value of word, right? And then it's try to run that command called word, but it's not finding, right? Look at the error message here. Hello, command not found, and then word, because I get the value of the hello variable here, that is word, and executed. And then it's try to execute, it's not found in the command. So that's the reason that I use the equal, just an example, as a command, how you can do, how can you print out the values of these variables. Okay? Any other question? Yes, there are, but I will not remember on top of my head all the restrictions. If you restrict yourself to start with the letters, numbers, and underscore, you're probably not going to have problem. If you start, if you put like dashes, then you might have problems because dash is also used as the character for the options, right? For the flags of commands. So there is a way around that, but if you restrict yourself to the usual letters, digits, and underscore, it should not be a problem. Avoid the special characters, right? The dollar sign, the brackets, braces, and so on. Okay? But I mean, there is a set that is of restriction. I just don't remember all of them on top of my head, but we can take a look later. Okay, so we have our shell, our command line interface, your shell prompt, right? And you might be asking yourself, okay, now I want to see my stuff. Where are my stuff, right? Where are my files, pictures, movies, and data? So when the terminal opens the shell, you start the shell on your home directory, okay? So this is the top directory of all your stuff. Everything is going to be laid down on that home directory. For example, in the mobile extern, your home directory is going to be on root home, / home mobile extern. On Mac, it's going to be on users and your username. On usual Linux system, it's going to be home and username. And Niagara and SciNet, you're going to have like home and then the first letter of the group, and the username. Okay? So usually this home directory is represented by the tilde symbol. So when you need to move around, this is very, very handy. Or when you need to write about a path on this, to find your file, this is also very handy. We're going to talk about this in a minute. So the directories are sometimes also called folders because how they are represented in the graphic user interface, in the GUIs, right? You see these little folders. But we're going to call them directories. So the Linux system directories, right? They are listings of files and other directories. So if you try to open that directory, what is in that file, you're going to see just a listing of files and other directories, right? Okay, if you are using the mobile extern, your home directory will be put on this persistent home directory. So is anybody using mobile extern here? Okay. So as you set in the settings configuration, right? So that's the reason that I ask you to set this persistent home directory so you can use as a home directory. Okay, we need, before we proceed, is a good idea to talk about the, yes. Yes. Okay. Okay, good for you. Okay, so we need to talk a little bit about the, we know, I just mentioned where your stuff is, right? But it's a good idea to talk about what is called the Linux file system hierarchy standard, right? It's basically, it's a tree where you define the structure of directories and files, where files are going to be located for whatever reason, right? It is maintained by the Linux Foundation. They take care of how we are going to create this tree, right? That it starts at the top here, for example, with the root directory, and how we laid out all the different directories. For example, here we have home directory, where all the users of the system will have their files and directories there. And here we have the etc directory, that is where the system admin will put the configurations specific for that system, right? And so on. There are zillions of different directories that you can lay out different files and software and so on. Okay, so okay, so here as an example of a tree, right, of this hierarchy, you have the root here, the home directory, the username, and the work and the README. So a directory inside the username, and then the README file. Okay, so you can specify the location of this file by just specifying the full path on this tree. Okay, so if you start from home, username, work, and README, that's how you find where the file is in this hierarchy, in this file system hierarchy. Okay? Do you have a question about this? It's just like to help you to find yourself in the system, right? The files and the needs to be laid down somehow in the system and needs to be organized somehow. So Linux organized this in a tree of directories, right? And every directory is going to have a function, and this is explicitly said in the standard. You can take a look later for you if you want to familiarize yourself a little bit more. But what we need here is just that you have this tree and how we find out where my file is, right? Where my movie, my data is located. So you start just going down the tree until you find the file, and then you can just specify the absolute path that it starts from the root directory until your file, okay? Okay, so now that we have this rough idea of how the files are laid out in your system, we should be asking, okay, how do I move around? How do I know where I am, right? So as I said, when you just start the shell, you are in your home directory. But yes, I'm just telling you that what kind of command I can use to tell me this and make me a little bit more confident of what I'm doing, right? So the first command that we're typing here is what is called a PWD, print working directory. It's just going to tell me, okay, right now I am on Niagara, right? On this directory here, intro Linux, that it starts from the root directory, so you have, and then goes to home, the S directory, SciNet directory, BeamOnDim directory, and intro to Linux directory. So it just goes down the tree until you find out where you are. Okay, so it just prints the absolute path, that is the path that comes from the root directory until where you are. Okay. And also, if I want to list the contents of that directory, right, I can just type it in ls, and then you can see the contents of my directory here. Basically, I just copy some PDFs, right, a tarball, the Newman that we're going to talk a little bit in a while, and I have some scripts here. Okay? Questions? Okay. Oh, also on the right here, I'll collect a list of the commands that we are using, okay, just as a reference. And at the end, we have like a sheet or a cheat sheet of all those commands that we typed today, okay? So in red, you're going to see the arguments, and if it has a bracket, it's not mandatory, it's optional argument. So let's download the data that we're going to use today to manipulate and play with a lot of commands, okay? So yes, in this example here, you are in the home mobile exterm, and then you just have some files there. We're going to type the command wget, and then this line here, support.scinet.uteron.ca / ej Spencer / command line.tar.gz. Okay, so type it in. And let me know if you're having troubles. If you probably if you're using a Mac, using curl might work better for you. You can just type it in curl-o, capital O, https / support.scinet.utoronto, and the same line. Okay. So we have these two options. If it doesn't work for you, you can also go to UFT or eduroam. Is the SciNet 3? If the SciNet 3 is there. I think it's capital O. dash capital O.
Yeah.
Oh, support dots, not forward slash.
Oh,
Yes.
this is the wrong symbol. I typed the right symbol there. Put that back.
What do you mean?
It's, it's not.
Yes, it is too.
Is it?
Yes, it is.
Then it doesn't work.
Right. What did you use here?
Enabling.
Okay, I think that you put 0. Yeah, the types are not very good.
Did you change?
The dash, you put dash 0 instead of dash capital O. This is a capital O instead of 0.
Yeah, okay. Okay, then
So I
that's
think-
fine. It works.
I think it works, right?
Yeah, thank you.
Oops.
It wasn't.
It is there. It is there. Yes, command line. Okay. Yeah, yes. So I loaded the command line .tar.gz on the website as well. If you're having trouble, you can just download from there. Yes.
Nobody there, right? When I check.
Yes, it's there. We can check ls. You see, yes.
Okay.
Okay, so did everyone got it? Did you get it? Okay, good. So the next step, this file is in a special format, right? It is basically called a tarball. And it just have the tarball is basically you have the several, let's say you have several files and directories, right? And then you want to create a backup of that, right? You want to create a backup that preserves all the characteristics of that file, right? The permissions and the last time that was modified and so on. So that's what is the tarball is for. You just put all those files together, right? Create this file. And in this case here, we also zip it. We just compress that in order to occupy less space, right? So to uncompress, to basically unzip it, let's just use this set of commands. So I use tar -x to extract, z because it's a zip file, and the name of the file, command line.gz. Okay, so you can type it in the options like this or the way that I did. Okay, but the last one needs to be -f because you're telling me what is the file to be uncompressed and untarred, right? So it's command line.tar.gz. Oh yes, I didn't comment before, but the wget it downloads this file, right? That is called tarball. Yeah, well, I think I just did comment. In the tar, we'll handle the tar file in this way, right? The -z will just do the GNU unzip, so it uncompresses. The -x extracts the contents of the file, so you have a tar file, then it just extracts that into the directories and files, and that -f specifies the file that you need to apply this command to. So if I do this, it will create a directory called data. What happened? Oh. So now I have a directory called data, okay? If you want to list the contents of data, just do ls, okay? Also, the ls, the list command, you you can have different flags to give you more information about what you're listing, right? For example, if you do a -F, capital F, it is going to list with some labels attached to that to tell you that, for example, here you have a directory, right? Okay. Yes. What do you mean?
So I type that in, and then that's
Yes.
Okay. So how do I get to that folder in order?
Well, just do ls to see if you are there. So you are
it's over
you
there,
have
okay.
there. Then you just do a tar. No. This is a tarball. Remember, you just tar -XZF in the name of the tarball.
Oh,
-XZF space in the command line. Yes. Now cd data, and then you see that you're there. Okay. Okay. So yes, we just use a command called wget or curl, and then you tar to extract the contents of that tarball. Okay. Now we can look at inside the data, but also before we do this, it is you might be asking, okay, how do I move around? How do I create directories, open files, and this sort of things, right? So we can play a little bit with that right now. Let's start with creating directories. Oops. So I'm here at pwd at my intro Linux directory. You probably you are in your home directory, right? I can list the contents of that directory with ls, and let's create the first directory. Make g first g. Okay. So if I list again with a -F to tell me what is a directory and what is not, you can see that you have the first G as a directory here. Okay. So let's create the second G. Make G. Yes, you could type it in the whole the absolute path as well if you want, but you don't need to. Okay, so there we go. You have the first directory and the second directory, right? Yeah, as I mentioned, the make G will create a directory, make a directory. In the -F here, we'll just add some labels to directories or symlinks like @ and so on, or a star if it is an executable. Okay. So let's move between directories. Let's just type it in here as well. So we want to do, let's create another directory. Make G. On your first directory, we call temp. So now we change, we use cd. cd stands for change directory. Cd first G. There we go. Now you can see my whole path now tells me that I'm inside the first G directory. Okay? And if I list the directories there, I have a temp directory. Let's go inside temp. cd temp. pwd, and then you can see that I'm inside its temp directory. Okay. Okay. If I type ls-a, it tells me it lists some hidden directories and files, right? Those hidden directories and files, they start with a dot. So the dot here means that is the current directory, and the double dot means that it is your parent directory. Okay, the parent directory in the hierarchy will just go up one level. So if I type cd ... I will go from temp to first D. Okay, so my absolute path now is going to look, it's going to stop at first D instead of temp. There we go. Okay. If I want to go to my home directory, that is the place that you start with, right, when you launch your shell, then you just type cd tilde. It will bring you back to your home directory. in my case at home as Signet BIM. Okay? And of course, if I want to go back to where I was, I just type cd dash. Then I go back to where I was. Okay? Is it clear how do we move around this hierarchy of files and directories? Okay. So some tips to move around, right? As I mentioned, the dot dot symbol represents the parent directory. The directory is up one level in the tree. And the dot represents the directory that is the current directory, right? So if you do cd dot dot, it goes up one directory. If you do cd dot dot slash dot dot, you go up two directories. cd dot dot other directory goes up one directory and then down to other directory. cd first D, second D, and then dot 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 dot. So that means you go down 2 and you come back 2. So that means you don't go anywhere. Okay? The same here, cd dot 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 dot, dot forward slash and so on. You just don't go anywhere because those just represent the current directory. Okay? Of course, you can use absolute path if you know where your file or directory is in the hierarchy. You just type it in, right? Starting from the root. The tilde means the home directory. So as we did that, you could simplify this. Instead of typing home mobile exterm, you just type cd tilde, and then that will represent your home directory. That is home mobile exterm. Then you just go there by typing like this. Also, cd without any arguments takes you back to the home directory. So the tilde is optional in this case. And cd dash goes back to the directory where you were previously. So as I did here. So just to show you, if I type just cd, I go back to my home directory. Okay? And cd dash, I go back to the directory that I was in before. Okay? Questions? Is that confusing? No? It's just a tree and how you move out up and down the tree. And some tips on how to move. Okay, there are some tips for using the command line as well. You can use some control commands. Okay, let's start with the tab key. That basically autocomplete the available options of the command that you are typing or the directory that you need to type and so on. So if you start typing your command, right? Let's see what is the example here. Okay, let's say grep. If I type gr, if I hit tab once, it didn't show me, it didn't complete any command because it didn't know which one. If I tap twice, then it tells me what are my options. If I want to type grep, right? And then if I type tab, it completes the name of the command that I was looking for. Let's see ls, but it's too short. Make d, mkd. What? Why is not? Okay, the tab just completes the command that you are using, that you start to type. So the shell will fill out the rest if there is only one option, and if there is more than one option, then you need to tab a second time, and then we'll list all the options, right? And then as you start typing in, it reduces the number of options, right? I think with grep works fine here. Then I start G, and then it finished basically. Right? I could type just grep, and then that's it. Control A and Control E. So let's say you type a command, right? And then you made a mistake, and then you type, for example, Control A, then the cursor comes back to the beginning of the line, right? Okay. If I type Control E, then it goes back to the end of the line. Okay. There are other control commands as well. Like if I do Control W, I guess, for example, I just erased that command, right? If I do another Control W, I erased everything, right? But you don't need to worry about those. Just those are the simplest control commands that you can use. There is also, as you type it in your commands, all of those commands are saved in a file, right? And it's basically you can access that file by typing the command history. And then you can scroll up and down that history. For example, here, if I type it in the up arrow, right, I can see the commands that I have been typing so far. Okay, I can browse them. Okay. Questions about these commands and these tricks? Okay, I'll move on. So history. Yes, you have as I said, these commands are saved in a file, and then you can access by just basically typing history, right? So I scroll up and down like the arrows, right? But if I want to see all the commands that I have typed so far, I just type history, and then it shows me all the commands that I've been using and typing so far. Okay. Yeah, in a session. The thing is that here I'm using my account at Niagara, so I have typing quite a bit there. So I have thousands of commands there. Okay. You can change the format of how it is spelled out. For example, if I put the shell variable his time format, and then I type it in this string here, for example, bracket, and then the format, the standard format for date, the standard format for the time. Okay, so I set it up, this shell variable. And now, okay, I can do something better. Let's put a space here. Now you can see, besides the number, right, of in the history in this buffer, I also know the date and the time that I type it in those commands. Okay, so that means it's auditable, right? If you want to know what you have been doing in the system, you can know. Okay. Okay. There are several history. You can, if you want to see only the last 10 history, you just type history 10. Okay. History is a rich command. There are zillions of things that you can do, and then you can use to access. I mean, if you want to search a command that you have typed, I don't know, grep, for example, and then it tells me that's the command that I typed, and then I can just rerun it, for example, right? Yes. Oh, sorry. Oh, okay. Okay. Yeah. So what are our commands so far? You see equal, pwd, ls, and make g, and so on. So these commands, they follow a philosophy that is what is basically the Linux philosophy, that you write a command to do something and only one thing very, very well. So you specialize that command to do just one thing. It's very different from what you probably are used to in the Windows world, right? When you have one software that tries to do everything for you, right? Here, no. We do like one command, one thing, right? And so that's very nice, because then you can You can combine commands to do complex tasks, right? But on the other hand, also, these commands end up being a little bit cryptic, right? You either know them or you don't know them, right? So, I mean, did you know that ls was for list or cd was to change directory? If you have never seen this command before, probably not, right? But I mean, as you go through and you learn more, you see that the names, the acronyms are okay, but there must be a way to find this, what these commands do, right? Or how do I find a command that does a particular thing, like a list directories or process a file, something like that, right? We're going to see in a minute that we can use a manual to try to find out. Yeah, so these commands take options. Usually you just have a dash and something as an indication of a flag, right, for this option. Yes, and as I said before, the purpose of this class is just that you have some familiarity with some commands, and so you can survive and move around the file system and get to know a little bit how to use them, not to exhaust all commands or all options of how to do that. So the man page, usually if you know the command, but you're not sure what are the options that are available, right? That's the place to go, right? You go to the manual of that command. For example, if I do man ls, it tells me, okay, ls, what is ls? It lists directory contents and gives you a summary of how to use it, right? You type ls, options in the file, and then this description, and then it goes on and on of all the options available for you, right? And usually it's a long list, right? And probably nobody is going to remember all of these options, neither experienced users. Usually we just remember the options that we use the most and that are the most useful for us, right? And if you need something else, usually you come to the main pages and search and see if you can find another option. And that's how you go collecting options as you go in life. Once you know all of them, then you basically die, because it's a lot of options, and you just retire and die. Okay. So, yes, okay, the mobile XTEM, they dumps all the man pages together. So there is a script, new man, that we put on the website that you can download, and that will prevent that from happening, okay? So yes, if you are not sure about a particular option, you just type ls. Before I go that, I mean, if you're trying to find, there is also man dash an option with dash k, oops, and then a particular word, let's say list, right? And then it tells you all the commands that has somehow that somehow deals with listing things, right? For example, listing available extensions and so on, right? And then if you are not sure, if you have a keyword and you want to use to try to find what kind of command you have, you could either ask somebody that might know, either ask the god Google, right? Or you can try also look at the man pages like that. You just type it in the keyword and search on these lists if you can find the command that is useful for you, right? Just want to mention that there is this option. Oops. What happened here? Okay. So wildcards, a star, it captures all possible combinations that fit a particular expression, right? A description. Okay, let's give an example here. Let's go into the directory data. I'll just go up one level here. Data. And if I list, you see all these directories, Alexander, Bert. Those are data. For our purpose, it doesn't mean anything. It's just like data with a couple of information about, it could be a medical information, you know, like anything. Information about some human beings, basically, right? So let's look the wildcard here, just for us to get familiar with. ls-d will list only the directories, right? So if I have sorry, yes, we'll list the directory contents, right? Let me just give an example here. If I type ls-d BERT, it will give me the, sorry, it will list not the, Jesus. Let me express myself better. If I do ls BERT, it will list the contents of that directory. But if I want to list just the directory name, I type ls-d, the option to list the directory. Okay, so now I'm not listing the directory contents. Clear? Okay, so now let's type it in the example. So I want to know all the directories that has the characters ER in it, inside that. So I just type star. It will be like anything before ER, right? Any character that is, any string that is matching that star, ER, and then anything after that. So if I type it, enter. So you see that here I have Alexander that finishes in ER. I have Bert that has ER in the middle. I have Gerdau that has ER in the middle. Okay. So if I want every directory that is ending in E, I just type like this. And then I have Lawrence. Okay. So it expands in all possible matches for that. Everything that it can find there. Okay? Questions? Okay. So let's manipulate a little bit of files, right? Let's see how we're going to copy or move files around. So, okay, where are we? We are here. Let's go to this Gerdau. I'm going to follow the examples. I'm going to type it in so you also can type it in and get some familiarity with it, okay? So if I type ls, so that's the data that I have on Gerdau. Yes. So if I type ls and then star 27 star, it will list all the data that has all the file names that has 27 in it, right? So data 0227, data 0279 has the file, has the string 27 in it. Okay? So now let's copy. CP stands for copy. Copy data 227 to data 0227 new. So if I do now, again, ls star 27 star, now I have a copy of that data called data 0227 new. Okay? If I want to copy that file, cp data 227, to the parent directory. So I just type it in ... Okay? And if I list what is in the parent directory, list ls ... I can see that the data is copied over there. Okay? And I can see also that the data is still here, right? The data 0227. I just copied that file. I didn't move. Okay? Questions? Okay. So now let's move the data. So here we are at Gerdau again. And we just did the ls. I'll just use my history here. And now let's move data 0227-new to a file called new.txt. Okay, ls star 27 star. Now that file name is not there anymore, right? So this is star. This expansion is at the file names level. It doesn't have anything to do with any content, if you might be wondering, okay? But if I do ls star txt, now you can see the new file name is there, new.txt. And we can move that file up as well. Sorry, you can move that file to the file name called .data0227. There's the file that I just copy one level over. And in my case here, because when I type in MV, I want to make sure that I'm doing something that is sensible and not deleting the whole root directory, I always ask the shell to ask myself if I want to really do that, right? I say yes, of course. But usually, because I do something called alias. Oops. So I just said, okay, move MV is actually my MV-I. And if you take a look at MV manual page and -I, it's going to tell me that -I is interactive. It's going to prompt, and it's going to ask me, okay, do you really want to do this? Do you really want to erase all your root directory? And say yes, no, okay? So it's just a trick to make sure that I don't have fat fingers, right? I don't do silly things when I'm erasing stuff or moving stuff around. Okay, so where are we? Yes, now if I do ls star text, you can see there is no such a file directory there anymore. And and the data is just that. Oh, okay, upstairs, oops. Yes, so the data that you have here is just the data with the new name, right? With the data 0227, okay? So yeah, move, you just move one file from one location, the directory tree, to another location, right? You can use also to rename the file name as well. So yeah, in move overwrites a file. That's the reason that I put that trick, to help me not do things too fast, right? Questions about copy and movie? No, okay. Okay, deleting. You can use the command called im, that it stands for remove, and basically deletes file, but it doesn't delete directories, okay? For deleting directories, you're going to see in a minute. Also, yes, you should be careful with remove, because we don't have a trash bin. We don't have a bin, right? Where you can just put your stuff there, and then if you regret, and I'm going to recover. No, if you remove, it's gone, okay? Again, I also put my commands, I also put the -I there for removing. Anything destructive, I want to slow me down when I'm doing stuff to avoid doing things that I don't want to do by accident. Okay, so let's do the example here. I am a data, ls, oops, I went too much. cd data. Okay, so we have this data here. And now, of course, what we have done before, that's the data. And then we want to remove that data. Then it's going to ask me, probably not for you. I said yes, and then I just remove. If I type 27 star again, no such file directory. Okay? So, okay, so removed a file. I just deleted from my system. There's no way to recover. You're gone. So you should be doing always like a backup. So whenever you do this by accident, you can recover that in from another medium. And I suggest you to put these aliases, so you don't need to worry, or at least it's slowed down, because it's very, very, very common when you're tired and you do things fast, and then all of a sudden you are doing things in a different directory that you want to, or removing a different file that you're supposed to, and so on. So you make mistakes. So it's good to slow down and think about what you're doing. Okay, copying directories. Let's go over here now. Let's call the maked temp, and let's copy the Gerdau data 227 to temp. So if I list the let me see what I have done wrong here. Oh, CP, not another little trick. I type it in, I mistype CD, so I mistype CD, but I want CP. That's another little trick. You don't need to remember that. Just copy the Gerdau data 0227 to temp. Okay, let's list the contents. The data is there. Now if I want to copy temp to temp to another directory, it's going to tell me that, oh, it's omitting the temp directory, okay? Because you cannot copy the directories in the files inside by default. If you want to do that, you need to do what is called the recursive copy, right? You need the cp-r. So cp-r, temp to temp to. If I list now temp to, we have. Did I copy this thing first? Oops, I'm in the wrong directory, sorry. So the data is there. One second, let's redo this. CP, I was in the wrong directory. Temp to temp to. Yes. So it copied the contents of temp to and put it there. Okay? Questions on that? Okay, let's move on. Deleting directories, of course. So we are here, the data. You do ls temp. We have data there. If you try to remove temp, it will complain that you cannot remove that directory, right? In order to do that, you need to remove the files inside the directories first. So Linux is one of the few commands that prevents you from doing silly things, right? Deleting things that you are not supposed to. So you can try to do, okay, remove temp, star, remove that regular file. And now I can, yeah, there's nothing there. Now I can remove the temp. Okay? And I could do the same thing for temp true. All the contents there, and remove temp true. Okay? Okay. Of course, there is another command that I'm going to tell you. Let's say right. So we try to do the remove D, right? And it doesn't let me, right? And then I said, okay, you erase all the contents of that directory first, right? And then you erase the directory with remove D. But there is another, you can use a flag on the remove itself that is basically say remove -if, -i is recursive and -f is to force, to erase, and the name of the directory. And it's gone. Forever. So you need to be careful with that, okay? Because if you go to the root directory and type remove -if star. That's it. If you're root, that's it, okay? So be very careful with this. Always take a deep breath before you're removing stuff, so you make sure that you're doing the right thing, okay? And always keep a backup of your stuff so you don't do things that we will regret later. Okay, questions? Okay. Okay, so looking inside files, right? There are a few commands that you can do to look inside files. Let's follow the examples here. And let's see with more first. So if I do cd Alexander directory, and if I do more data 560, it tells me what is inside. Here is just a report, right? And tells me, oh, okay, a set of data, basically, right? A subject, the name of the person, year, date of birth, sex, and whatever this means in terms of biology of this person, right? And so on. Then if I type Q, I just get out of that screen, and I can move on, okay? So it's just one way of listing the contents of that file. There are others. You can cat, that means also concatenate. If you look at the catman page, concatenate files and print on the standard output. If you use cat for just one file, right, like this, it just concatenates and prints only one file to the output, right? Okay, another one is less. Data 560. You also can see the file there. Okay, so we have these three. They are a little bit different. I think here you can't see much of the difference between more or less, but you can see between cat and the others, right? So can you tell me what it is? Yeah, the cat prints in the standard output, and the less and more, it basically opens some sort of like a buffer to do that, okay? And then you can move up and down on that as well. Okay, let's concatenate the files together, right? So if I do this ls data, I have all the data sets here. If I want to concatenate all the files, and then I put this greater than sign, that basically, okay, let me talk a little bit more about this. So the files are going to be used by cat as an input, right? So that it can concatenate these files. And then cat will print out that to the standard output, right? And the standard output in this case is just your screen, right? But we don't want that. We want that standard output to be actually redirected to a file. And so that symbol, like the greater than, is just telling you that. It's just redirecting whatever should be printed into the standard output. So if I do this cat star data, it will print everything to the standard output. But I want to redirect that to a file. So call all data. That's it. Nothing came out to the screen, and everything that I show earlier, all this information here, it is in that file. Okay. Oh, by the way, I just typed vim to access that file. Vim is an editor. It's another way to look inside the files. It's a very, very powerful editor. It's the one that I like the most and use the most. And then you can see whatever it is inside that file. If you if you're following me, you type the vim, you can just do column and Q to get out, or basically capital ZZ if you want to be fast, like this. Oops. Okay. Let's show what is less doing here. You have what? Try just VI to see if it is installed. Yeah. Yes. I mean, VI is a basic editor, should be in your system. So here, for example, I'm using less, okay? And the thing that I wanted you to realize it is, okay, if I do a cat, so I like VI, and it's kind of a war, right? Well, try Emacs. Emacs is another editor that is also very powerful. Yeah, Nano. Yes, that's true. But you cannot do much with Nano as well, right? So the two most powerful editors is Emacs and VI. I like VI because it's more economical. And yeah, Emacs you always have to use the control keys, but you can go a little bit more basic and use Nano. That is another editor that tells you what to do basically as you type it in. Okay. But it's just one line. Well, as soon as you learn how to do it, that's it, right? It's not very difficult, but it's very powerful. Okay, for example, here I concatenate all the files and then printed into the standard output. As you can see, you would have to scroll up to see what is in that output, right? However, if I do less, it paginates for you. So every amount of number of lines that it fills in your screen, it stops and shows you the data. And then if I do page down, and then it goes down, right? And then I can look at the data better. I could go up and down as well as with the arrows, right? So it's a convenient way to look into the data. You cannot modify it, just looking at it, right? And to get out of it, you just press Q. Okay, so redirection, as I said, initially you have a command and then you put the greater than sign that will redirect the standard output, whatever it is spitting out into your screen, to a file that you give a name here. Okay, if you want to append instead of just open the file and write there, you can use the two greater than signs together. In this case, the contents of file will not be erased, and they will just append to the end of the file, right? The new contents of the new output of the command file. And of course, you can use the less than sign to give the standard input, in this case a file, to a particular command. Okay, so it takes the file as an input to that command. So those are the three basics redirection operators. So let's see how it goes here. If I want a cat and then use all data as an input file, I just did that. I just redirect that to cat. Okay? Okay, I didn't tell you. So, yes, what's the time? Yes, let's take like 10 minutes break. Okay. Should I stop here? Okay. Yeah, so. So I brought the shell command cheat sheet that you can do some use afterwards. I printed some of them. You can just keep at your desk. Give another one for him. Okay. So, okay, let's start again. Let's talk about a few other commands. So you have already like a large list of commands, and I just gave to you a cheat sheet, so you can keep it on your desk all the time, so you remember the name of the commands and at least how to find more information about them by typing man and the name of the command, right? So our list keep growing, and then it's not going to stop ever. So the number of commands grows quite fast. So let's see another two of them now, head and tail. So they print the head prints the first 10 lines by default, and the tail prints the last 10 lines by default of the input that you give them, right? So let's see how it goes. I am in the Alexander directory. Is this? Let me put it a bit more like this. And okay, head. If I want to print only the first 4 lines, I put the -4 of data. And as you can see here, you have like a space, 1, 2, 3, 4 lines, okay? If I do less data, as you can see there, you start from there, right? 1, 2, 3, 4 lines. Okay. Okay, so let's see if you wanna equal the string nice into all data. So it just appended that string to the last line of all data. Now if I do tail, I'm gonna tail -5 all data. It's just gonna print the last 5 lines, right? So 1, 2, 3, 4, 5 lines, the last 5 lines. So if you see with less, go to the end, you're going to see the last 5 lines here. 1, 2, 3, 4, 5. Okay? So basically that's what these two commands do. Again, like one simple command to do one thing very, very well. Okay? More info about the command, you always type man and tail, and then you're going to see several different options that you could use here. Okay? One that is particularly useful is the -f, that will follow a particular file that is open, and as the file is written there, okay, good. As the file is written there, like if you do, it's good for following a file that is being written all the time, right? Tail -f and the file name, for example. Okay. Word count. That's a nice command. Okay, we are here again, Alexander. So if I want to count the number of lines, words, and characters of all data, I just type WC. Okay. If I want to know the number of lines, WC dash L of data, it gives me 442. So the first in the output here is the line, then words, then characters. So line, then if I do the W is words, and if I do WC, C, characters. Okay? So now if you want to know the number of words in all of these data files, that's there you go. You just do WC-W star data. So it basically gives you all the number of words on each of these files and give you a total of that. Okay? So is that clear on how to use WC, word count? Okay. So file type and location. So the file command will try to determine the type of a given file. Let's see how it goes. If I go to cd, if I type file, okay, so where I am now, I am at the data directory, okay. If I list, I have these files here in directories. If I type file, Lawrence, it should tell me what kind of file it is. Remember, my list, my ls is labeling here and telling me there is a directory, but not necessarily, right? ls doesn't need to label that. If I do like the command ls, let's see. You see, I don't have any labels, any colors, right? I would have to add a -f to give me some labels there, right? You see the forward slash telling me that is directory. In any case, my point is here is that the file command can give you this information about the file or directory, whatever it is there. It's telling me there is a directory. Okay? Now let's see what the file tells me about a data set there. 554. It tells me there is an ASCII text. So here, an ASCII text. Okay. The command which. So we're going to try to find where the command is located, right? It will look. It will look where the program is, basically. So let's see here, which wget. It tells me that the command is in the /user/bin/wget. So you can find where the command is, right? And if you want to know what the command is, what kind of file the command is, right? It could be a script, it could be an executable, what kind of executable, right? So then you could do a file user bin wget and tells you there is a executable and linkable format file, basically an executable in Linux. Okay. Yes, here is a different executable because the example was run in Windows. Yeah, similar to which you can have where it is to find files associated with a particular command. And of course, you always can do a man of the command as well, right? So let's see, where is ls? It tells me where ls is and where the man page of the ls is. Okay. Is that clear how to use file? What kind of information it does? It gives you? Okay. Okay, comparing files. There's a utility called diff that allows you to compare two files, right? And gives you the difference between them. So let's see here. diff Alexander data 216 against Alexander data 242. So it basically reports what are the whatever it is different on the first file as compared to the second file, right? And tells you and anchors that on the line 2, for example. It's the difference starts on line 2 until line 9, from column 2 to 9. Okay, so that's the example. Yeah, there is a nicer format if you wanna, if you like it. If you put -u, and if you are used to version control systems, you have the same sort of like a unified format, right? It tells you on the first file, the minus is the first file that is being compared to, and the plus is what is added to the second file that is being compared to. Yeah, vimdiff is another one with the VI interface. Let's do it here. So it basically highlights which lines has differences between them in pink, and then in red what the differences are, right? Like, for example, the year and month of birth here is different. One is 95, the other one is 94. February, January, right? So it's very nice for you to pick up the differences quickly on the files, right? I use this all the time. Yes, we saw the diff in vimdiff. It's very nice for working with text file. There is also diff3 that works in comparison with 3 different files, right? I don't use that much. Yeah, vimdiff also can handle several files. Usually I'm comparing most of the time 2 files. But it's not useful when you're dealing with binary files. For that, we need to use a command called CMP. So you compare byte by byte. So yeah, there's a story that's interesting that a long time ago I was a TA, and then I suspected that 2 students were basically cheating, right? And because it was supposed for them to type it in a long Maple. Maple is a symbolic algebraic software, right? And it was supposed for them to type it in all the commands of a long Maple worksheet, right? And they were like very similar because I was grading them, right? And then I used this command to find out that it was actually very similar, identically similar, basically the same file. You use the CMP, you could find that, right? And they try to justify, no, we typed together. No, there's no way that you are going to make the same mistake typing these files, right? There's going to be an extra space, an extra line. There's no way, right? So that's how I got the student cheating using this command. It's useful to compare binary files, right? Okay, find. So yes, find, for example, if you're trying to use all sorts of files in your directory, right? Wildcards are very, very useful and powerful, right? Let's follow this example here. If you type ls, okay, let's go to the Alexander here. If you type ls star, sorry, 00 star, oops, I think I should have gone, not cd, Bruno, ls. So then it lists all the files that has 00 on it, right? So here, for example, in the birth directory, Frank, Richard, and Lawrence, you can find all of them. All the files that has 00, one level below, you could find. So this is very powerful, very nice, but it is limited, right? And the limitation here is that it stops at the first level of directory. If you need to do that, if you had like more levels of directories inside, and if you need to do this recursively, it wouldn't be easy to do with this wildcard. Yes, there is newer wildcards that will allow you to do that, but let's forget that for the moment, okay? So my point here to justify the use of find, there is a tool that will do that for you very easily and very quickly. Okay, we will find this on all the levels below the directory that you are. So let's see an example here. So in print directory, if I type find and print, you don't need to type print, but it's a usual way to do it. It will look at the files that start with a dot on your current directory, and will print the results. Okay, so you can combine several different things with that. You can use several different options about these files. For example, here, if I want to find the file that has find on the current directory and recursively inside that directory, the files that has the type file and the name that matches this regular expression here, 09 star. Okay? So it finds these three files that will have the 09 on the name, right? And it is of the type file. So it's not a directory, for example. It's not a symbolic link, or it's not a pipe or socket or something else, okay? Yeah, should I mention this? I'll mention quickly. So, for example, find. You just find a file with this particular name. You could do more advanced commands as well. You could combine this with another option that is called exec. And then if you want to find inside this file a particular string, let's say range, I don't know if this string is there or not, but let's just mention this. And if you want to, this should be quiet, so just put this, the shell. No, let's do this. And then you just use the exec and use this these braces that will just be a text placement, and then you close the option. You close the command for exec with this semicolon, but you escape it so the shell doesn't interpret. Then you try to find out the files that have those range. Here it was not useful because I just grabbed them and then just show me the lines that are supposed to have those regular expression. But I could call, instead of the lines, tell me the file names, for example. Then it would tell me, oh, those files names has this particular has this particular data inside it, right? So it's a combination of commands that I find very useful. You find the type of files that you're looking for, and then you also execute a particular program. In this case, I'm just looking inside that file and see if a particular string is inside that, right? So this is a very nice command to use for find in combination with other commands. Okay, very quickly, if you have questions, we talk about this later. Okay, so far we use the following techniques to combine programs, right? We just redirect the data to a particular file, and then we open that file into the terminal, right? So, but this combination is very, very common, right? A lot of commands output prints the results in the standard output, and a lot of commands get those results from the standard input. So they created what is called a pipe. That is a way to chain the standard output of one command into the standard input of the other command. So you can chain several commands together in one line, in making what is called a pipe or pipeline, right? So for example here, I could do wait data count, oops, data star, oops, I'm not here, cd Lawrence, word count data star, and then I could pipe to more. That's it, right? So the standard output of one command went to the more, and then it's paginating for me until I get to the end, and then I press Q and then get out of that buffer. Okay? The sort command. So as the command name implies, it will sort the output in a particular way, right? The main flags that we should be worried about now is the dash n, that is, will sort by number. For example, not lexicographically. I mean, 101 is not less than 30 as a number, but it is lexicographically. So 1 comes first, then 3. Okay, so that's the reason that we use the dash n. And then we can use the dash k and the number of that will sort by the column number num. Okay, and that dash r will reverse the order. Okay, so instead of ascendant goes descendant and so on, just reverse order. So let's type it in the command, the example here, where I am. I forgot the directory that I was. Alexander. Okay, so if I do sort numeric, the column 3, all. Oops, did I miss something in the example? Yes, I definitely missed. CD Lawrence, W count, word count, data, star to all WCs. Okay. Now we're good for the example. Sort numeric K3 all WCs. So now it's sorted by the column 3, right? 1, 2, and 3. So it's sorting numerically. So the numbers are advancing, right? 147, 48, 49, 50, and the total 7,644. Okay. Yes, there is another way that you could do that. You could combine the commands in a pipeline. So you could just do WC data star, and that will generate all those word counts, right? But then I just pipe that to the command sort. So the output of that command will go to the sort, that will sort numerically by the column number 3. That's it. Okay. Of course, if you want to reverse the sort, I just type dash R. Oops. Yes, mistyped. And then we reverse. Now we're going to see the smallest number instead of the biggest. Okay? Okay, so now let's play a little bit, a quiz. So you want to modify this code to print only the smallest. So you want to see only the smallest of the results, right, by the column 3. So you want to see from all only the smallest. And then you're going to modify again to print only the largest data file. Okay? So let's do this quiz. Don't look ahead, please. Try. It's not hard. So does anyone have an idea what kind of commands you're going to use to combine them? Which kind of commands you can combine to get this result? Suggestions? So I'll just type it in to give you so you have data, and then you sort that data into N, K3, and prints all this data. Now I wanted the largest, I wanted the smallest data file. So here you count this, the largest data file by the number of characters, right? 153, for example. And the smallest, if you reverse as I did before, like 144. Okay? So how do I get this command, this set of commands that I combine through a pipe to print only the smallest, and then afterwards only the largest. So you have just learned a set of commands that will help you with that. No, I want it in a pipe. Through a pipe. Yeah, I mean, you could copy to a file, open the file, select that, and then print to the standard output. Yes, no, I don't want that. I want something more automatic, that I just print the output through a pipe and then process it, and at the end I just have one line with the solution. Yes. Yes, head and tail. So you can use them as a combination to get that solution. Okay, so let's try. That's maybe 5 minutes at most. And if you have questions, just raise your hand and we'll help you. Okay. Does anyone has a solution? So let's see. So in this case, this solution here is just giving you what? You pipe to head dash n equals to 1, dash n1 or dash 1. That will just print the first line, right? Because if I do this less, so the first line here is already sorted as being the smallest data set, right? So I could just head dash 1. Okay? So let's see the biggest. So the biggest is a little bit more complicated in the sense that you have to combine the two commands, right? So if you look at here, the biggest one that I want to extract is this one, is the second last, right? So let's start doing this, and then okay, let's do the way the example is doing. I could do it differently, but that's okay. Dash R. So dash R is going to reverse, and now I want to see the last, the first two. Okay, so I reversed, and now the first two is going to be the total and the largest file, right? Now I can just tail them like this. And that's it. Okay? Yes?
What is the purpose of -n?
It's just another way of writing dash 1. It's just the number of lines. If you look at oops, sorry. So dash n is just going to be the output of the last k lines, right? But you could write just the number as well, as I did. Let's see if it is here. Interesting. It doesn't tell me. So both ways are just the same. Okay, just a different way of writing that. Okay, is that clear? Yes.
I obtain the total. I obtain the total and the.
Say again.
When I put n1.
So let me reproduce what you're doing. When you put n1 like this.
Yeah. Same as the total.
Did you put the head dash n2 first, or maybe the dash r? How did you do? You know, like first I reverse the sort, yeah, and then I get the first two, and then the last one. As I reverse, then it reversed the orders, right? The total is going to be first in this, and then I get this last one. Okay, more questions? Is that clear? Okay, so let's move on to the next. Okay, so now we're going to write down our first shell script. We saw a lot of commands, right? And as I said before, the good thing about the text shell or the command line interface is that you can put all the commands that you have used so far in a file, and then you can reuse over and over again, right, as you wish. So let's start doing this as our first program, right? Let's see. So yes, you can try to use the mobile text editor, or if you are in Linux or Mac, you can use Nano, Emacs, VI. Okay, I use VI, but you can use Nano as well. It's up to you. So let's put what we have just done into a file called biggest. Okay. So vi biggest. So I will start with what they call sharp bang. They call like shebang, like a short name for that. And what is this? This is just magic number that tells your system that this file is to be executed and interpreted by a particular interpreter. And the interpreter that I'm using is bin bash, that will look at these files and run the commands, right? It could be Python, could be Perl, right? Could be Ruby. It depends on what you're doing. In our case, it's bash, okay? And let's see, we're doing word count star. Then I pipe to sort, also numeric, and I want to sort by the column number 3. Then I pipe to tail, get the last 2 of them, and then I pipe to head and get the first one. That was the solution that I was going to type it in earlier. Okay, so we are good. I'll type this solution just for you to take a look. Selection is not working. It's Windows. Oops. Oh, Jesus. What did I do? Yeah, I'm back. So if I type the solution here, sort 3 and then tail minus n2, that will give me this guy's tail, right? I just get the last 2. And if I want to adjust the first one, I pipe to head, and then I get that one. Good. Anyway, so now let's remove this guy, and we can source the biggest. That will just run all those commands that is inside that, and it will give me the solution. Okay? That is exactly this command that we typed in before. Okay? So that was our first shell script. Permissions. You saw that I used the command source, that they will just source that file, just run those commands, right? But I could type it in the file name itself if I change the permissions. If I tell the operating system that that file is an executable, you can execute. How do we do that? First, let me show you that what we have here. Biggest. So it's telling me, okay, what is this permission telling me? The permission is telling me that me as you, okay, first, the first dash is telling me that, okay, this is a regular file. And then you have these three first places. The first one is telling me that this file is readable, it is writable, but it's not executable because I don't have an X here, right? And the first 3 here is by the user, by the owner, by me, okay? The next 3 is by my group, by Signet. And the last 3 is by others in the system, okay? So all you need to do is to change the execution bit. The user, I want the user to be able to execute. I want me to be able to execute. Okay, so now it is an executable. So you see that biggest has a star there telling labeled as an executable. I can do again an ls. Oops. And now you see that we have an X here telling me that it is executable by the user. Okay? So that's basically permissions in a nutshell, very, very, very quickly. So if I want the others to use as well, I need to give them permissions, give them permission to read or execute, right? Now what I can do, I can just type it in, dot, in the current directory, I have the executable called biggest, and then it would just be executed by the system and give me the result on the standard output. Okay? Where are you trying to write? Is it what system are you using?
I'm using
Did you set up your home directory?
sometimes it does, sometimes it doesn't.
I have the same issue. I just have to like press escape and then I, and then it lets you insert text.
Oh, inside VI?
Yeah.
Yes, you need to go to the insert mode. Yes.
No, it's working now. I don't know if that helps you.
Yeah, but I think he's probably asking about the mobile extern, right?
Yeah, for example, whatever.
Now you type I. Now type anything that you want. No file name and the cursor. I'm not sure what you did here. Okay, type I. Okay, it's working fine. Ask to get out of that mode, and then if you want to save, you do WQ. Try to use nano for the time being. It's easy. Okay, did you guys catch up? Okay. Okay, so we just set up a file with the commands that we want, and we change the permission so we can execute that file instead of just sourcing it, right? So now let's see, okay, another command that I think I just mentioned briefly earlier, grep. So what about the range of the largest range? So let's take a look on one of these data files here. Data 352, okay? So there are several fields there, and one of them is basically called range. So we look at what are the largest data file and what is the smallest data file in size, right? Now, if you want to see, okay, what is the data file that has the largest range? For example, here range, this field is just 2, right? Is there anyone that has a larger one? So the command called grep is the one that will help us to find inside that file the information about these fields, and then we can pipe into sort to help us with this quest, with this question. So let's see how it goes. So for example, yes, you can grep a range on all these files, and then we give you all the range that we have, right? Then if you want to sort, right, I'll just type it in here. Okay, if you want to grab the files that do not have range, you put the option V. Sorry. What I meant is that if I want to find the contents of the file, of a particular file, only the contents, only the lines that do not have the range pattern, right? Then you can put the -V. It reverses the search pattern. So before you have only the line that has range, right? If I take it out, this is dash V. Only the line that has range. Now only the lines that do not have range as a pattern. Okay? And if you do, oops. If you do this, you just picked up this line or not. Okay? So basically, that's the essence of grep. You look inside the file and look for pattern, right? For regular expressions. Okay, we have another pop quiz. We have to create a new script called biggest range, which prints out the data file which has the biggest range. So 5 more minutes. Do we have time for that? Yes, I guess so. So remember that you already have this script called biggest that you can put inside this script, right? Or not, I don't know. Okay, so shall we see how we can do that? Okay, so biggest range, let's type it in the solution. Biggest range. So the shebang bin bash. So whenever you have just one line that starts with a sharp or hash, that is a comment, okay? Just to make sure that it's not going to be executed by the shell. So then we try grep range if you want, right? And then star. Then you pipe to sort. You want to sort numerically by the column, by the second column, and then you tail -n1. That's it. That's your script. Let's see how it goes. Oh, let's change mode for the user to execute. Biggest range. Oops. Okay. Now if I type biggest range, it will give me the range of 9 for the data file 0531. Okay? Yes. So basically, I grab a pattern. The pattern is range. The star will expand to all the data files in that directory. And then I pipe that output into the sort command. I sort numerically. That's what the -n tells me. And I sort by the second column. If I just do grep range star, let's take a look. What does that do? So the first column is the data file, the pattern range, and the second column is the number. So I'm sorting numerically on this second column, right? So this is the first column. Then you have a space, second column. Okay, so that's what the sort numerically by the second column here is telling me. That's the second column, that's numerically. That's what it does. And then at the end, you're going to have the largest range at the end, right? And then you just tail prints the last output, -n1. Is that clear? So that's what it does. Question?
It's trying to update file name.
Oh, you want to? Yeah, you could. You could. I mean, that's what I was trying to do earlier here. What I did, but we're not going to talk about this today. There is a command called awk that I usually talk in the advanced course and at the end. That basically prints the column that you choose, right? So the -f column, it tells me what I called a field, right? That will separate the columns. So I chose the column because I want just the first name, right? And then I print the $1, that is the position of the first column. $2 would be range. $3 will be the number with the space. Okay? The data number. That was what you're looking for? Yeah, okay. So yeah, I was happy with this solution like this. Yes, but at the end you can put this awk function as well. Okay? Okay, cutting up. Okay, yes, there's the cut as well. We're just gonna talk about it not. So cut, it will cut the output, right? You could cut by characters, or also you could define a particular field, right, that you want to use as a descriptor to cut. Okay, let's see the examples here. Grep star sort dash n k2 and then tail dash 1. So now you want to get only the first the first name, right, of the file. So here you could use cut dash c. If you look at the manual page of cut dash c, it says that select only these characters. Okay. Oops. And then you did I do something? Yes. Yes, it selects only those characters, and only, for example, only the first 8 characters. So first m character includes or byte or character or field, right? So you put the dash m. So here would be dash 8. Cut characters, the first 8 of them. If you count the first 8 characters, it's exactly the name of the file. Okay? So it's a way of doing that. Suppose that you want the range, right? So let's go back here. So you want only the range, from the range onwards. So the first 8 character is this, 9 is this, 10. So you start from 10 until the end. To the end. There you go. You'd have the range. So you cut the strings as you want, right? Have the string and then you cut them. Yeah, you could cut from the character 2 to 5 as you did here, right? 2 to 5. So at the 0, something like that. Okay. So yeah, I use awk much more than I use cut because I think awk is more powerful. But it's something that is more advanced that we're going to learn later, the next course.
It's dangerous if you have sort of data.
Yes, it's not robust, right? Awk is more robust, as they could have different length in names, right? And then you could always print that column. So yeah, that's why I prefer awk. Okay. Okay, suppose that I need to save my information. Okay, I think we mentioned this before. Save into whatever you want into a variable, right? So, for example, here, the example is saving the information into a variable called I. So that's what we will try to do. And Control A to the beginning. We're going to call I equal. Here the modern way and the classic way. The classic way is basically like command output. You have the command and you're going to output you're going to redirect the output to this variable, right? So the shell executes and the output is going to be saved on this variable I, right? The classic way is to use the back code. Okay, if I do this and now I do equal $I, I have the data name there. Okay, if I just do equal I, remember that it's just the name of the variable. It doesn't tell me what is the value that is loaded there, right? For me to access the value, I need to put the $sign. Okay, that's the classic way. And then we have what is the modern way. Instead of using this, we just Instead of the back quotes, we just do the dollar sign in parentheses, and it does the same thing. Okay? So is the back quote, this guy here on your keyboard, okay, that you could use. So then, yes, you can save this this information into variables, right? If you use like the single quote, then it's just a string. It doesn't save anything, right? It just save the value of the string. Let me put here. So we did this, and then if you do, but if I do a single quote, okay, now it's going to save the whole string of commands, right? In this case, a little bit more because it expanded, the shell expanded the dollars, the star. There was a shell expansion for that. I mean, I could do the following. So you have the star there as well. Okay. Okay, arguments for bash scripts. So sometimes you wanna give some argument like the name of the file, the name of directory, or something that you wanna pass to your script, right? And in the shell reads that argument and put in what is called the positional built-in constructs, right? That is the $0, $1, $2, and so on. The $0 is the name of the command. $1 is the first positional argument. $2 is the second one, and so on, right? So let's follow the example here. Okay. So Ahmed Lawrence. Biggest range up. Let's edit this guy. So now it's going to accept the name of a directory. So we put $1 in braces, and that directory, and that's it. Okay. So if I type it in the biggest range, and I think the directory was Alexander, for example, it's going to tell me the data that has the biggest range, right? That is 10 on this directory. Okay? Clear? I type it in the command, the chains. Let's see. Okay, and yes, we are here on the data. And now we want to do the biggest range on BERT. It finds the biggest range, the data file that is there with the biggest range, right? If you want to do on the other guys, on Thomas, that's the same. So the data files are here all similar. James, it does the same. Okay? If I try a directory that doesn't exist, like James, you just tell me that it doesn't exist. Okay? So that's how you pass arguments to your bash script. You type it in the argument there, and in the bash will just interpret each argument in order. So you have the first one that is going to be $1 for that first argument, $2 for the second, $3 for fourth, and so on. Okay. So the braces is basically it is optional, but you need to be careful. If it is embedded in a string, the shell might not interpret very well. So that's the reason that we put the braces. So it will make sure that it will interpret that as a positional argument that you should expand over there. So they just expand that $1 as the name of the directory that you give as an argument. Okay? Okay, so what do we have next here? A loop for bash scripts. So loop is just a way to recur and do the same set of commands over and over again, right? So let's write a quick loop script here that is going to use the biggest range. The biggest range is here on the local directory. Let's call loop biggest range. So again, shebang bin bash. Then for d is just the name of the loop variable. Just call d. We could call just I. You could call whatever letter you want, right? Let's follow the example. In Alexander, Bert, then is a list of things to loop over, right? So here's the name of the directories. Frank, Richard. Then you do equal. Then you have a string like called d biggest range in. Then the shell variable d that is used in the loop is. Oops, I think I'm doing something wrong. No, that's okay. Yeah, you could do this. Biggest range. Done. Okay. Change permissions. There we go. So the biggest range in Alexander is, oops, what did I do? I think I did a mistake here. So the biggest range in D is, we want to execute this guy here. Not equal. Not print out to screen. There you go. So the biggest range in Alexander is Alexander blah blah blah. Okay? And the biggest range in Bert is this, and so on. Okay? So the loop just, oops. The script just loops over these options, right? These options is listed here, right? After the in special token. So you have for, d, in, and the names. And then you do a set of commands, and you're done. Okay? Is it clear how to do a loop? A simple loop on lists. You have any questions about this? Yes. The $d is here for d in these guys here. So D is going to be replaced by these names in order, right? First, Alexander comes here, then the next loop, Bert comes here, and the next loop, Frank Richard comes here. Okay? Questions? Okay, so let's move on. If statements for bash scripts. So it's basically very similar to other languages, right? You just put if a particular condition is satisfied, then do something else, do something else, right? And so on. So let's type it in this simple script as well. If test.shell. Oops, not visual. Okay. Bin bash. So you're gonna go here. You're gonna change it to the directory for file name in star do. Then you can do if statement here. If, dollar, put the string also in quotes, file name equal to notes. There's a better way to write this. I like to write this like this. Then equal I am a notes file. Finished. Done. Okay, so the if statement has a syntax if, and then you have the bracket where inside it you're going to test for a particular condition. Here I'm testing for the condition that the file name, the string file name, is equal to the string notes, right? If it is, I'm going to print to the standard output, I'm a notes file, okay? And this is looping. The first argument is going to be the directory name, and it's going to loop. First, you're going to change to that directory, and then you're going to loop over all the files there. The star here is going to expand to all the files there, and then you're going to loop on each of those files and ask if those files are nodes files. If it is, it's going to equal that in the standard output. What? Semicolon here. Yes. I mean, yes, you could do the then in another line. The semicolon just finish the command, right? Ah. What are the chances? Okay, so let's change mode here as well. Oops. And now let's try the if. And let's follow the example. I'm a notes file. So if I do James, I can see that there is a file there with a file name called notes. Okay? Is that clear? Good. So we are running out of time. I'm going to speed up a little bit. Basically, we got there. I thought I had a few more slides. No, you got there. So yeah, basically this is it. If you want to log out of your system, you just type log out, and then you're going to log out, and finished. Control D also works, right? So yeah, this is enough for today. Just should remind you that these commands, they are not complete. We just have a set of commands, right? And a little bit of the flags that you can use as options for these commands. But there's a lot more. You can always find more about them, look in the manuals or Google them or asking us if you need. But one thing that is very common to all these commands in the Bash, in Linux in specific, is that they're very simple and designed to do one task very, very well, right? And this feature allows you to combine them to solve more complex tasks, right? So then I hope that you got the taste of how they work, and then you can do whatever you want to satisfy your needs, to solve your problem, right? And if you have any questions, please always send us an email at support@scinet, and then we can help you, okay? So yes, and at the end we have the shell common cheat sheet that I sent to you, I gave to you. So please use and abuse of this sheet. It will be helpful, especially in the beginning, okay? Okay, thank you.